Yes, let's continuing it. Now in this case, we have made cis and trans isomers by exchanging the position of ligands. Now, as I have told you, in case of scale planar there are more than two type of bond angle, that is 90 and 180. So let's observe that whether changing in the position is changing the nearest environment of the ligands or not. Now in this case, just let's observe the position here. Ammonia. Here ammonia is in the nearest environment of this Cl and this ammonia, because they are at the nearest bond angle 90 and 90. This bond angle is 180, so it is not the nearest environment. Fine. Now here the nearest environment I am writing here is ammonia and Cl. Now same ammonia is now here. Let's observe its nearest environment here. Here the nearest environment is 2 Cl atoms. 2 Cl negative ions. 2 Cl ligands, right? So in this case you clearly observe that changing the position of the ligand is changing their environments. So that means in case of scale planar there exists geometrical isomerism because environment is changing. Okay, now let me take the next example, next type of scale planar complexes, and the example is M, A, B, C, 2 type. Now in this case, complex of complex of platinum is there, like this, in which Py is pyridine. Pyridine is an organic compound, it is an organic base, structure is like this. It is a monodentate ligand, right? So in this particular case, while making cis-trans isomers, remember we are not making cis and trans isomers. These compounds already exist in that spatial arrangement around the central atom. But just to make you understand, I am using the word we are changing the environment, we are changing the position like that. Otherwise, the two different isomers are already available in that particular form. Now, in the first case, in such case, while making cis and trans isomers, just observe the two same ligands here, pyridine, keep them on the adjacent position, and that will be cis isomer. The other ligands can be at any positions. Fine. And while making its trans isomers, you have to keep them diagonally opposite, like this. Fine. So as a result, you can see changes in the environment. Here pyridine is in the environment of pyridine and ammonia. Fine. But here the same pyridine is in the environment of chlorine and ammonia, right? So in this way geometrical isomerism is created. So this is the second example, that is MABC2. All of them are monodentate. Fine. Third case, we have very important MAB twice. I have already told you that this AB is a bidentate ligand. Therefore, the coordination number in this complex is 4. The one of the common example is a complex of platinum, right? Remember, platinum is more common in forming scale planar complexes. Twice. Now, glycinate. This is the small symbol used for GLY. Glycinate ion is this. It is a bidentate ligand with two different donor atoms. You see here, one donor is nitrogen and one donor is oxygen. So when such a ligand is present, then only then the geometrical isomerism is possible. Fine. Now let me make this example here. If you keep the two same donors on the same side of the structure, then it will give you a cis isomer like this. You see, oxygen, oxygen same side, nitrogen, nitrogen are on the same side. So this particular form is cis. So if little bit changes in the position in the space, suppose I am keeping this ligand in the same position around central atom, but the other one is now like this. So you see here, nitrogen, nitrogen are diagonally opposite, oxygen, oxygen are diagonally opposite. Fine. So this creates a trans isomer. Fine. So this is the second category, MAB twice. Let me take the third category among square planar complexes. Sorry, this was the third. The fourth category is complexes which are not very commonly known because they are not very stable. All the four ligands are different. So in this particular case, I am just making a general example here. The three structures are possible. One of the ligand, if one of the ligands position is changed with respect to other three ligands. For example, here it is A, B, C and D. Right? Now I am exchanging A with B. B, A, C, D. Now I am exchanging C with A. It is B, C, A and D. Fine? So these three isomers are created. Need not to call them cis and trans isomer, but they are general, they are considered as geometrical isomers because in each case environment of A is different. See, A environment is BD, A environment is BC, A environment is CD. In all cases the environments are different, and if you examine any one of A, B, C, D, you will see that there will be changes in the environment and no more further structure will be created. If you create the fourth one, there will be same type of environment, that means nothing new will be created. So this is the square planar complexes of A, B, C, D type. Now, we have discussed geometrical isomerism in square planar complexes, cis and trans isomerism. Now we'll come to the second type of geometrical isomerism and the second coordination number category, that is ML6, that is octahedral structures. Right? There are 6 ligands, or we can simply say coordination number 6 is there around center matter. Now, while discussing this, cis and trans isomers in this case, we have to understand different positions around the metal in octahedral structure. Now these are the 1, 2, 3, 4, 5, 6 position. Let me number them. 1, 2, 3, 4, 5, 6. Now here, the adjacent position, while considering the geometrical isomerism, adjacent positions are taken as cis positions. For example, 1, 2 position is a cis position, 2, 3, 3, 4, 4, 5, 5, 6 and 6, 1. If the two same ligands are present on these two positions, then that will be taken as a cis position. Fine. Then similarly, there are trans positions also. The trans positions are diagonally opposite positions which are present here. For example, 1, 4 is a diagonally opposite position. 2, 5 is a diagonally opposite position, and 3, 6 is also a diagonally opposite position. If the two same ligands are present on these positions, that will be considered as one trans position. Fine. So in case of ML6, we also have certain categories. So in this case, we have first category, the most simple one is M